In this video, I want to show you how you can use our application in order to execute some cheap-16 instructions. After that, you clone the repository successfully and also change your directory to the repository directory. You can, or you have actually to head to the project directory, which is in our case cheap-16. There you can, for example, build a project, or you can also test a project. After that, you build a project successfully. You have multiple options. Either you can use the binaries or direct or executable directly, or you can use cargo run. And then you can see the logs here. But also, I have two monitors right now. Therefore, um, I had the application window on the other monitor, but now you can see the application also. And here you have more or less two sides. On the left-hand side, you can see two items or two panels. One of them is a code editor where you can write some code, and on the left bottom or bottom left, sorry, you can also see the action buttons. You can use them to take some actions on the code that you wrote. Um, and on the right-hand side, you can see an overview of registers that we have. We have 16 registers, and also you can see the status registers that we have that can, but not must, um, get updated after instructions. And if you want to kind of update them, you can pick in the documentation. You can see the syntax required for updating the status flags. And down there, you can see also two panels. One of them is for application logs. For example, if you or if I right now click some buttons, you can see some application logs. They kind of document your interaction with the application. On the right hand side, you have another panel which looks similar, and it is there in order to document the execution logs. For example, um, if you use the log instruction from cheap-16 um, instructions, you can also output or print some register value, and then you can see it there. And as you saw, probably after that, I try to build and flash the code. The registers values are and status registers are updated. Um, we do it this way because we want to kind of randomly initialize registers so that we have an approximate simulation or better simulation of a real processor. And here you can write some code. It's important to note that our parser kind of needs indentation in order to differentiate between labels and also instructions. This one is a, a label, since you do not have any tabs or any indentation, but this one is an instruction, right? That's the difference. And you have this differentiation in various assembly derivatives and syntaxes. But let's get started with some code um, writing and also execution. We can start simple. We can, for example, define a label. Then we can um, assign a value to a register. We also support various types of literals. For example, I can here write two, and as you can see, we have a hexadecimal value here and also a decimal value here. Then we can add them both. For example, R0 and R1. Again, if you need more information on the syntax, you can check in the documentation or more precisely the instructions to architecture. And you will find also some examples and some notes on the syntax. Then I can write the value in R3, and then we can also log some values. And then we do not have two, but we can have a label for the end of the program. And then I can, again, build and flash, and as you can see, we have to save the code. We can save the code. I take a default name, and it doesn't really matter. And then you can see that the project is not the project, but the file is saved to the current directory, and then you can build and flash. And as you can see, our logs get updated after each interaction. And in this case, we could actually compile the code, save the results, or more precisely said, the binary encodings of instructions, and then also you can we and also we could successfully load the binaries. And in the next step, you can see that the action buttons panel kind of get updated, and you can see some new options here. You have three options. With back, you can go back. I have to show it to you once. In this case, after that you build and flashed your code, you cannot change it anymore. It's a similar behavior like most of other environments or development environments. But if you want to change your code, you can go back and then you can change it, and then you then flash the code, and yeah. And then you have two options. You have one option for execute the code once. In this case, your code will get executed um, at once. I mean, every single instruction, and you can see only final results. For example, if you write some other values into R3 after this line, you will see only that result because it's a fire and forget type of execution. But you can also debug your code by executing it stepwise. And after that, you clicked on it again, the registers got flashed, or the emulator or processor got flashed, and also all registers got randomly initialized. And as you can see, you have here multiple options. For example, you can uh, use next step button in order to go to next step. And as you can see, our program counter got updated after each line execution, but also the value of R0 got updated. You could probably see that red box. And then after that, we can continue with the code execution. And as you can see, R1 is also updated, and then we can add them together into R3. And you can see also the result here. And then we can output the R0 value here, and then you're done, right? You could achieve the same thing by using the execute. But before that I show it to you, I wanted to show you something else. If you are in the stepwise execution, you can also reset. You can jump back to the beginning, and you can do the same thing. And you can also stop the execution, or better said, stop the debugging. And then in this case, you get redirected back to the last stage. Okay, and in this case, we can also execute the code, and as you can see, you will see only the final results here, and also the output of log. And we can go back. We have also some code examples here that you can use if you want, but also you can write your own code. I hope that this video will kind of help you comprehend how or understand how you can use our application. Thank you so much for your attention.